Storm Mushry, Conservation Education Manager with the New Mexico Department of Game and Fish. And today I'm really excited. We're going to have two of our fisheries biologists giving us talks or presentations on electrofishing. And I think you're going to find this fascinating. It's one of those that in my career as a district officer, I've been able to go out a few times on some of our reservoirs and also some of our rivers or streams to be able to assist our fisheries biologists on some of these projects. But with that, I will let them go ahead and introduce themselves, but we're going to have Jane Trujillo and Edward Enriquez that are going to be visiting with us today. So from there, I'll let Jane take it away.
Thank you, Storm. So my name is Jane Trujillo. As Storm mentioned, I'm a cold water fisheries biologist for the New Mexico Department of Game and Fish. I've been with Game and Fish for almost 5 years now, and I'm the cold water fisheries biologist for the eastern side of the state. So that means that I spend a lot of my time on the eastern side of the state, but I also help statewide on lots of other projects too. So today, we're going to talk about stream electrofishing, and then I think Edward is going to talk about the reservoir aspect of electrofishing. And I want to talk about more than just what an electrofishing survey is. I want to go over why we do electrofishing surveys and how we do electrofishing surveys from beginning to end so that you get an idea of the whole concept and hopefully can learn a bunch from it. All right, so first off, what is a stream electrofishing survey? Well, simply put, it's a process that we go out and we collect information about fish that live in an individual stream or river, a flowing water. This information lets us learn about the fish community in that flowing water. And so there's a couple of terms that I'd like you to get familiar with. First is the fish community. I've said that a couple of times now. What does that exactly does that mean? It means all the fish that live in a given place at a given time. So if you went out to a stream and you just took a snapshot at that time, the fish community would be whoever's there. So it answers that question of who's there. And then this other term is lotic, which basically just refers to flowing water. And so there's lots of examples of flowing waters in New Mexico, even though we're a very dry state. These are places like the Rio Grande. They could be acequias throughout Albuquerque, or mountain streams like the Pecos River. So anywhere where water is flowing. So we've introduced a little bit about what a stream survey is. And now I'd like to talk about why we do a stream survey. So there's a lot of reasons why we do a stream survey, but it all boils down to long-term monitoring. Long-term monitoring allows us to have information about the fish communities living in these flowing waters throughout the state of New Mexico. And then I'd like to talk a little bit more about the different aspects of long-term monitoring that are beneficial for us to know about. So the first in line is fishery changes. So when we do stream electrofishing surveys, it tells us what the long-term trends of those populations might be. So if you look at this figure here, on the right, we've got number of fish over time. On this scale, it's years. So if we have, 20 years, 30 years of information, that can tell you, well, where the fishery was and maybe where it is at a later date. And with that, we can make decisions to help improve fisheries through time. And again, so if you look at this timepiece right here, if that's the data that we're looking at, then we can be like, well, it looks like there's been a downward trend. Maybe there's something we can do at that water to help improve that. It allows us additionally to evaluate regulations. And regulations, I just wanted to put a little bit more about what I mean by evaluate regulations. So there are specific fisheries regulations that are rules and laws that are put into place to achieve a desired outcome. And so this might be something like making sure that the fishery remains stable over time, even if animals are harvested from that population. So if an angler's out fishing, they can only keep a certain number of trout a day. And that ensures that the next person that comes along and fishes in that stream will be able to catch fish as well. So here's one example of what we call special trout waters in New Mexico that have different regulations. So a red chili water would be a catch and release water, but a green chili water would be a water that has a 2 trout bag limit with tackle restrictions. So long-term monitoring allows us to evaluate these regulations. If we were going to change from a red chili water to a green chili water, we would have information about before that regulation change, and then information about after that regulation change. Long-term monitoring also allows us to select areas that might be good for specific projects. And what I'm getting at here is that we can identify places that might benefit perhaps from an in-stream restoration project. And we've got information on the fisheries community in that stream because of these stream surveys that we've done. Long-term monitoring also provides us information that we can share with anglers if we get calls, which I take phone calls from the public all the time. And somebody might call me and ask me, well, I want to catch a Rio Grande cutthroat trout, but I don't really know where to go. I've got at my fingertips at any given time, I can look this information up and suggest places for that angler to go fish. It also gives us a baseline in the event of a catastrophe. So if there's an environmental disaster or a very devastating forest fire or something like that, we've got information about what was in that stream before that catastrophe occurred. All right, so we talked about why we do stream surveys, and we talked very briefly about what a stream survey is. Now I'd like to talk a little bit more about what information is gathered during a stream survey. And you can break this down into 2 components where you've got information about the stream, and then you've got information about the fish living in that stream. So we're interested in who's there. That tells us a ton. Are there brown trout? Are there Rio Grande cutthroat trout? Are there both? And that is really informative, like I said before, especially if somebody calls me and they want to know where to fish for a specific animal, I can tell them where to go. We're also interested in how big the animals are. So if you look at the figure on the right, that is an example of a rainbow trout, and we measure total length. So that's from the snout to the very end of the tail. And then we also measure how much they weigh. In addition to the size of the animals, we're also interested in how many are there in the stream. Are they like this first stream on the left, which would be considered very dense, or are they not as common throughout the stream, so you might only have a few fish at a time. This again helps me answer angler questions. If somebody's like, I want to go catch as many fish as I can get, where do I go? This gives me some sort of basis to suggest that information. And so the next 3 parts are the stream aspect of what information we gather. The first 3 were the fish information. So it tells us stuff about stream size. We can measure things like stream flow, which tells us how much water is moving through a particular area. We can measure characteristics of the habitat. So this might include things like the temperature of the stream, maybe the canopy cover of the stream. And as you can see from these 3 photos, these streams all look very different, which is typically the case in New Mexico. We have a lot of diversity when it comes to types of streams and rivers. And then the final bit of information that is often of interest is what food is available in a particular stream. If you've ever turned over a rock in a river or a stream before, you'll realize that there's tons of little critters living underneath that rock. And so that is an indication that fish are probably in that stream, and fish probably do well in that stream if you see lots of little critters under rocks. All right, so here's the fun part. How exactly are the stream fish surveys conducted? So there's 7 steps to an electrofishing survey. And first, we trap the fish in a 100-meter section. So we do this by setting what are called block nets. So if you look in this figure right here, that's a net that we've stretched across the width of that river. And then we move upstream 100 meters and set another block net. So the individuals that are in that section can't move outside of that section. Next, after we've set the block nets, we strap on our handy backpack electrofishing units, which look kind of like something from Ghostbusters. But basically, they're powered with a little tiny battery that's right here. And then this is the anode on the front end, which is the positive end. And then you can see right here, there's a cable that comes down, and that's referred to as the cathode. And so what happens is when this user compresses a button on the pull right here, it creates an electric current around that individual. And so you can see right here, that red portion, that's a button that you switch on, and then it pulses that electric current through the water. And so when that happens, the fish gets stunned, and then you have some helpers following you along with nets that scoop the fish up as you move upstream. And that, like I said, it stuns them, so it's temporary. And you usually have somebody following along with a bucket, and they put the fish that you've captured in that bucket. And when you get to the top of the reach, you've sampled the whole thing. We take our fish from our buckets and we put them in these little baskets. Then we measure their length and their weight. To make sure that we don't catch these fish again, we place them in net pens outside of our blocked off section. So there's no way we could catch them again. Then we repeat this process until we've achieved depletion, which depending on the stream, it usually only takes 3 passes, but I've been on surveys before where it takes us maybe 4 or 5 passes. For example, this picture on the far right would be very hard to electrofish. So you might have to do more than 3 passes on this one because it looks like it's hard to get nets in there. Looks like it's probably hard to get around. And then when we finished our depletion, we release the fish into the stream and then take any kind of stream measurements we might be interested in. In addition to temperature, we might measure the dissolved oxygen level, which is important for fish as they breathe through their gills. So we take a measurement of width in a bunch of locations, and this will help us in determining the density of fish in the stream. Okay, so we've went out and done our stream electrofishing survey. Now what do? We collected a ton of information. So the next part of stream electrofishing survey is the numbers. And so we have all this information. It's really important that we've got somewhere to put this information. So we put it into a computer program, and that does calculations for us, which makes our job much easier. And then we can put this information into graphical displays and reports. The database that we use to store all of our stream surveys is referred to as a stream survey database. And as I mentioned before, it allows us to store all of our information in one place. So if somebody calls me and is like, I want to know about fish in this stream, I can look it up and have all of the information from the last 20 years of surveys right in front of me. And in addition to sport fish, we also collect information on non-game species, such as long-nosed dace. And this is really helpful for understanding what goes on in the community beyond sport fish. With this information, we can look at figures such as this length frequency histogram, where we've got the number of fish and then the fish length in inches. So from a figure like this, we'd be able to look here and say, okay, it looks like a large number of fish are between 0 and 3 inches. This to me would indicate that we've got good reproduction in the stream, which is really important for maintaining long-term sustainability of stream fishes. So we went through this process. We went out, we collected fish, we measured the fish, we wrote all this information down, we entered it into a computer, and we generated figures and developed these reports. All of this gathering of information allows us to use observations from these stream surveys in order to make decisions to improve fisheries throughout the state of New Mexico. With that, stream surveys inform management. They allow us to manage the public's fish effectively over time through long-term monitoring. And they also provide outstanding opportunity for anglers through use of information. With that, I wanted to thank anglers, as they're responsible for a lot of the conservation that goes on in the state of New Mexico. Revenue from license sales and taxes on fishing goods and tackle and things like that promote conservation throughout the state of New Mexico.
Thank you, Jane. I enjoyed that presentation immensely. I learned a lot myself, and can't thank you enough for taking time out of your day. I know you guys are very, very busy, so and appreciate everything you all do for the state. Our next presenter is going to be Edward Enriquez, and with that, I'll let Edward take it away.
My name is Edward Enriquez. I'm one of the warm water fish or sport fisheries biologists for the state, and specifically I'm the black bass biologist for the state of New Mexico. So Jane went ahead and covered electrofishing in streams and rivers. I will go ahead and focus now on reservoir electrofishing surveys. And this includes any other smaller lakes or ponds or any water bodies like that that are essentially still water bodies. So a reservoir electrofishing survey is a collection of information about, in this specific case, black bass populations in New Mexico's waters. And a black bass population is considered to be all the black bass that are living in a given reservoir or lake. And so another term to kind of keep track of, just like with the river situations, is lentic. So lentic is inhabiting or situated in static freshwater. So examples of these would be Bill Evans, Conchas, Elephant Butte, Navajo, or Ute, or even anything as small as a pond as at Alumni Pond at NMSU or the Duck Pond at UNM. So the three species of bass that I'm primarily concerned with in the state of New Mexico are largemouth bass, smallmouth bass, and spotted bass. Largemouth and smallmouth bass are pretty widely distributed throughout the state. Spotted bass are pretty much confined to the eastern half of the state. We have a good population in Fort Sumner or in Sumner Lake, and we also have a good population in Lake Carlsbad, there in the city of Carlsbad. So why do we do these reservoir surveys? We can do long-term monitoring, just like Jane had mentioned in her talk. So we can look at changes to the fishery. We can use this data to evaluate regulations, length limits, bag limits. We can also use this information to evaluate management actions, such as supplemental stocking of additional bass or habitat restoration efforts. And that would also give us an idea as to what projects we can move forward to. We also use this information to inform anglers. And then we can also use this information to keep track of populations in the event of some sort of catastrophe. So similar to what Jane had showed earlier, we can look at the fish, how the fish population has changed over time. We can look at how that population fluctuates in terms of numbers. And for the reservoirs in New Mexico, a lot of that does have to do with fluctuations in the reservoirs, especially here in New Mexico, as dry as it is and as limited our rainfall and snow can be. So in looking at evaluating regulations, we can look at either changing length limits or bag limit changes for black bass or for largemouths. In general, the length limit's 14 inches. Several years back, we looked at changing the length limit for smallmouth bass in Conchas and Ute, and that decision was made primarily because of what we were seeing from data collected from the electrofishing surveys. And so what I have here is on the left is a picture of some largemouth bass that were stocked into Elephant Butte. So that's supplementing those populations. And that's based on looking at survey data that we had previously collected. Here on the right-hand side are where this is at Bill Evans Lake, and we're adding habitat to add more complex structure for smaller juvenile fish. We can use that long-term monitoring also to look forward and look ahead. Habitat restoration projects are what we've looked at, and we're looking at other water bodies where those type of projects would help the fish population, and that's based on these surveys, or looking at pit tagging studies, and like I mentioned before, supplemental stocking of those water bodies. And if you look closely here in the center of this picture right here, there's me apparently pretending to be a bass. I know Jake took that picture just because he probably saw that my head was sticking right through that hole perfectly. And informing, anglers, we can inform them as to the population structure of the fish at a particular lake, the size structure. Are there more fish that are of bigger than 5 pounds in this reservoir, or what kind of diversity is there in terms of the species? Is there more largemouths rather than smallmouths, or are there even any spotted bass in a specific reservoir that they do want to fish? And like Jane mentioned earlier, the anglers can call us directly. Our numbers are listed. So there are days where you get a call and somebody's like, I want to go fishing the Bill Evans. How is the fishing there? Are there a lot of big fish, but are there not too many of them? And they can ask us those questions directly. And then we do also use this information to kind of keep baselines just in case of drought. And as you can see there on the right, that's a picture of Elephant Butte. I forget what capacity it was at this point, but it was somewhere in the range of less than 5%. And that lake should be expanded all the way up to this shore over here and all the way up to this shore over here. And then it should actually continue all the way on through up through this picture. But obviously you can tell how bad it is. And then we can also use that information in the event of chemical spills where we have fish kills or toxic algae blooms where we may get fish kills as well. So moving on to how are these reservoir fish surveys done? Obviously, it's done a little different than a stream survey. We use an electrofishing boat, which I believe I have a picture of on the next slide. But before we even get out, our survey sites are randomly selected on the water body. And depending on the lake size, we do between 3 to 23 sites at a lake, just given on its size. Bigger lakes get more survey sites, smaller lakes, less survey sites. And all these surveys are conducted at night, and we typically start a half hour after sundown. And there's the electrofishing boat right there. It looks like we're at Bill Evans Lake in this picture. So once we get to our first site, what we would do is we have a device called a Secchi disc, and it's just a disc. And I wish I had a picture of it here, but what it is a disc that we drop down into the water. It's black and white. And what we use that is to determine the water clarity. We drop it until we can just make it out. And it's the rope that we use to drop it with is notched. And we can tell, okay, I can see it down to 1 meter, going past 2 meters. Okay, I lost it at like 2.5 meters. And we use that to determine the water clarity. We have to have a minimum water clarity of at least 1 meter before we'll go ahead and conduct the surveys. If the water isn't clear enough, it's obviously going to make it harder to see the fish and to net them. So what we'll typically do is once we go through one site, 2 people are usually on the front of this deck right here netting, and we have somebody driving, and we'll typically also have somebody sitting back here that helps the netters get fish into the live well. We'll hold all those fish from that one site in the live well. Once we finish going through our 10-minute run, which is the time that we typically allocate for doing one of those survey sites, we go for 10 minutes. We'll stop, we'll measure and weigh fish. We'll take scales from them so that we can age those fish and get an idea for their age at their length and look at other growth factors with that. We'll then release the fish, and then we'll go on to the next site, and we'll do that throughout the night until we've finished all the survey sites we have for that water body. So essentially the information that's gathered, we record what species, we get lengths and weights, we can calculate fish density, which is catch per unit effort, which is the number of fish that we can expect to capture in an hour. We can figure out some other, this is a body factor parameter. This is called relative weight. Ideal range is 95 to 105, and all it typically means is how plump or how fit a fish is. And this kind of tells us that the fish are finding enough forage and that we don't have any prey base issues. If it's really, really low, then that's something to look into. And the higher the value is, we can infer from that, well, they're finding plenty of either fish or crayfish or other aquatic prey items that they can eat. We collect scales or otoliths, and we use these to age the fish. And then once we get finished surveying, we go to data analysis. So we take all the data that we collected from the surveys, and we enter all of this into an electrofishing survey database, which we use Microsoft Access for this. Access can calculate our relative weight values. It can calculate the catch per unit effort, and it can also calculate our proportional stock densities. And all this is looking at the ratio of the number of fish that are stock size and above as compared to the total sample of fish that are greater than stock size. So then after that, we can start graphing the data to kind of visually, to visualize that data to kind of show us, like this chart here is an example of Lake Sumner, and it's just a species composition chart, as you can see right here. In the black is largemouth bass. Here in this kind of dark gray, smallmouth bass, and here in this lighter gray is the proportion of those individuals that were spotted bass. And we can also graph out using the information from the scales or the otoliths. Here on the x-axis, we have the age of the fish in years, and here on the y-axis, the length of the fish. And we can get mean values, and we can determine and tell anglers, so a 3-year-old fish will be just over 300 millimeters in length, which is just over 12 inches long. And we can give that data to anglers. And we can also do length frequencies. Here on the x-axis, we have the length class of the fish in inches and the percent of the sample that they represent. So in this population from Ute Lake, we have a good proportion of the population that are above legal harvest size, which is 14 inches, which is 14 inches right here. And most of the individuals, or a good proportion of the individuals, are over 12 inches. So next, after that, once we've summarized all of that data, done our data analysis and graphed all of that information, we submit our federal aid reports, and we submit these annually to the U.S. Fish and Wildlife Service Agency. And it's so that U.S. Fish and Wildlife is interested in how we are spending that federal grant money. And we have, those federal grant monies are tied to certain projects. So we submit a spring black bass survey report to the U.S. Fish and Wildlife Service every year. And that is all of our information summarized from our monitoring surveys. And now here, of course, because what everybody always likes to see in these presentations are our big fish pictures. So this fish here in the center right here was caught out of Bill Evans Lake a couple of years ago, and it weighed 11.6 pounds. Here, this was like in the upper left corner is one of our game wardens with, I believe this was like a 5 or 5.5 pound smallmouth bass I believe that was at Ute. And then down here in the bottom left is another one of our game wardens that went out to help us with, I believe that was a 9-pound largemouth bass out of Clayton Lake. And then over here on the right-hand side, I'm in the back. I don't know what I was doing, probably trying to get a data sheet, and Eric here thought it was a good time to take a picture with that big 11.5-pound largemouth bass. And so to kind of wrap up and conclude, I would like to thank all the anglers, their licensed dollars support conservation and management, as well as their purchase of rods, reels, lures, and baits, and motorboat gasoline. That all goes towards sport fish restoration, which is some of the monies that we use for these surveys. And this right here is from this past year's survey at Bill Evans, me all covered up with one of the nicer largemouth bass that we had caught during that survey.
Thank you, Edward. I found that very interesting. Both of you did an excellent job presenting the material. I loved it, and can't thank you enough. And I know Jane, she gets off the hook today because I had her on our fisheries roundtable discussion. And it's one of those that she was able to answer a lot of questions. But I've got one question for you today, Edward. If you can kind of think back, like when you were in high school and maybe even mid school, but maybe in high school, if there were certain classes that definitely helped you out, helped you prepare more for, you know, getting your degree in college and getting into the profession of fisheries management?
So let me first start off with saying that I dislike math. And in saying that, I'm not trying to discourage anybody that already doesn't like math away from math, but I fortunately had a advisor in high school who would, despite my protests, put me into the advanced math courses. So I did my, at least at the time, it was you did your algebra 1, geometry, algebra 2. And then I was very surprised to see that the next semester I was going to be taking trigonometry. And then the semester after that, I was put into calculus. And I remember at the time I did not like it, but those two courses probably helped me a lot once I got into college. And then once in college, you started getting into the business and biological calculus, which is what you need for, or is a course requirement for this degree, at least at New Mexico State University. I don't know if it's like that. Still, I would assume that it is. And then I would also say that it also helped me a lot in statistics as well, because you do have to take a couple of statistics courses. So I would say that those taking those extra math courses that aren't required helped out a lot. I always was interested in biology and science and stuff like that, so I took those courses anyways because that's what I wanted to be in. But I would definitely say that taking that trig course and the calculus course really did help me out a lot in the long run. Again, despite my my reluctance to participate in those courses, but yeah, I would say those two, and then also of course any biology courses you can take or chemistry while in high school. And then I think something else would be taking more advanced English courses or writing courses, because that also will help you a lot, especially if you want to pursue a master's degree or higher degrees past a bachelor's.
Well, cool. Well, thank you, man. I can kind of relate to math. I know I wasn't the best in math, and I know once I was in college, had to take several statistics classes, and I honestly fell in love with it. I love doing statistics, and it was always interesting you'd have one statistic problem, and by the time you got done, you had about 4 pages that you had worked on just trying to figure out what the answer was, and it was just always fascinating to me. But with that, we'll end today's recording, and I can't thank you both enough for joining us today, and I hope you all enjoyed it, and we'll see you on the next video. So have a great day.